All right, good morning, guys. I am recording this lesson because I have to be out this afternoon, so I'm recording for first period class. So if you have any questions, if you'll raise your hand, I'll answer them. Today we're going to be talking about angles of elevation and angles of depression. The homework is on page 583, number 1, 2, 4 through 7 all, 13, 15, and 20. So you want to put that down. I'm not sure if it's what's on your syllabus or not.
So that's going to be due Monday?
Yes. It will be due Monday because we won't meet tomorrow. Okay. All right. So I have a question. Who is this person in the slide?
Zorro. It's Zorro.
Zorro. Right. And if you watch the old pictures of Zorro, he always made a Z on things like tree trunks and stuff like that with his sword. So can y'all draw a Z?
Yes.
Yes. Okay, so draw a Z on your piece of paper.
Like a big Z or a small?
A big Z.
That's not big enough.
That's big enough. Alright. So, on your big Z, we're going to label the parts. This line, which I'm going to make through here, is called the line of sight. So I'm going to label it A, B, C, and D on my Z. Alright, so that line that runs from C to B is a line of sight. Okay? Alright. So then we have this angle, which is angles A, B, C. And if you're standing on this angle, are you looking down or are you looking up?
Down.
So it's a angle of depression. See how it goes down? So it's an angle of depression. So that's angle A, B, C, or we might call it angle 1. Alright. So then we have angle B, C, D. Maybe. Which we'll call angle 2. And if you're standing in that angle, are you looking up or down?
Up.
So it's an angle of elevation. Okay. Everybody good? Alright. So I would like to review a couple of things that we've learned prior to this before we continue on. Okay? So, the first thing I want to review is the sine of theta, cosine of theta, and the tangent of theta. The sine of theta is equal to the opposite of the hypotenuse. So if you're standing here and you walk opposite, it will be y over r, because because R is opposite right angle. And Y is opposite the angle. So R is the hypotenuse, and Y is opposite. The cosine of theta is equal to the adjacent over the hypotenuse. So X is adjacent over the hypotenuse, which is R. Then we have the tangent of theta is equal to the opposite of adjacent. So opposite is Y, adjacent is X. Alright. So then I want to review parallel lines. The information we know about these. You know that if two lines are parallel, that alternate interior angles are equal. What two angles, or give me some alternate interior angles? Wow.
So angle 5 and angle 3.
So alternate interior angles are angle 5 and 3. What do we know about alternate interior angles if these lines are parallel?
They're congruent.
They're congruent. Alright, give me another pair of alternate interior angles. Cool. 4 and 6. Okay. Alright. Then the next thing we want to review is alternate exterior angles. What do we know about alternate exterior angles? They're also congruent. So that means a pair of alternate exterior angles are, Mitchell? 8 and 2, good choice. And what else?
7 and
1 and 7. Alright. Good. Alright. Next we want corresponding. What do we know about corresponding angles?
They're congruent.
They're congruent. Okay. Who wants to give me a pair of corresponding? So 7 and 3. 4 and 8. 5 and 1. And
2 and 6.
2 and 6. Alright, good. Alright, lastly we have same-sided interior. And what do we know about same-sided interior? They're supplementary that equal 180 degrees. So a pair of same-sided interior.
6 and 3.
6 and 3. 4 and 5. Alright, good. Anybody have a question about that? Everybody remembers all that? Okay, good. Alright, so that takes me to this picture. Alright, so we know that the word elevation means to go up. So we just looked at this picture that we drew. So who wants to give me the angle of elevation? Oh, angle 1. Okay. What about the angle of depression? Who's got that? William back there? Angle 2. Good. Alright, who's got the line of sight? Cole? Okay. Line ZR. Okay. Alright, good. Alright, so on my picture you see where TR is parallel to ZY. So what does that tell you about angles 1 and 2?
They're congruent.
They're congruent. That's right. So we know, that angle 1 is congruent to angle 2. Okay? Everybody understand that? Good. Alright, so, once again, going over it again. Line of sight is RZ or ZR. Angle of depression, angle 1, and the angle of elevation, angle 2. You know that angle 1 and angle 2 are congruent if this is parallel to that. Okay. Well, I have this building up here. This building right here. I have this building over here. So what's the line of sight?
RM.
RM. Okay. What's the angle of elevation?
Angle 2.
Angle 2. Alright. Everybody understands that. So that takes me to my first example, which is the first problem on the page that you have. So it says, the angle of elevation from point A to the top of a hill is 49 degrees. If point A is 400 feet from the base of the hill, how high is the hill? If you don't have a picture in the word problem, draw yourself a Z and make the picture. Alright, so on your paper that I gave you, we want to calculate this. So we have a picture that looks like this. We have that this is 49 degrees, they told you that. This is 400 feet, and you're asked to calculate the height of the hill. How high is the hill? Alright, so we have to use either sine, cosine, or tangent. Why did you choose tangent? Because we don't have a hypotenuse and we're not looking for it. So we're going to say the tangent of 49 degrees is equal to the opposite of the adjacent. So write yourself an equation. If you can write the equation, you can solve the problem. And I want to see the equation. Then we want to move 400 to the other side of the equation. We get 400 times the tangent of 49 is equal to x. So in your calculator, you want to say 400 tangent of 49 and you should get 460 feet. So x is equal to 460 feet. Any question about that? All right. On the next problem, it says, find the angle of elevation of the sun when a 12.5 meter tall telephone pole casts an 18 meter long shadow. once again, if you don't have a picture, draw yourself a Z. I'll draw the Z. It says angle of elevation. So we're looking at this angle right here. So there's our telephone pole. Here's the sun. We don't know this angle. That's what we're looking for. This is 12.5 meters, and this is 18 meters. So are we looking for a degree, or are we looking for a side?
Degree.
We're looking for a degree. So do we have the hypotenuse?
No.
No. So what are we going to use? Tangent. So we're going to say the tangent of x is equal to the opposite over the adjacent, which is 18. When the variable is closest to the word, and you're looking for a degree, you're going to hit second tangent, which is actually called arc tangent, and you're going to put that in your calculator. So second tangent, and then 12.5 divided by 18. Close the parentheses. Get in the habit of closing the parentheses, y'all. And we get that it is x is equal to 34.77 degrees.
How many decimal places do you want us to?
I think it's probably best to have 2 decimal places, but I think your textbooks ask for 1. So go to mode. Go to mode.
Hit float and do 2.
All right. And change your float. Let's just go ahead and put it on 1. I think your textbook asks it for 1 decimal place. Okay. Everybody good on that one? Problem number 3. Once again, if you don't have a picture, draw one. It says a ski run is 1,000 yards long with a vertical drop of 208 yards. Find the angle of depression. So, what's the angle of depression? This is the angle of depression. So we're looking for this angle. Alright, it tells you that this is 1,000 feet. And it says that that is 208 yards. Okay, well remember that these are alternate interior and they're equal. Okay? So that angle is equal to this angle. So, do we have a hypotenuse?
Yes.
Yes. And what are we looking for? We're looking for the degree. And do we have the opposite or do we have the adjacent?
Opposite.
We have the opposite. So we're going to say the sine of x degrees is equal to the opposite over the hypotenuse. The variable is closest to the word. What are you going to hit? Second sine. So, and we're looking for a degree. So we're going to say second sine, and then 208 divided by 1,000. Remember to close the parentheses. We get 12. So it is x is equal to 12 degrees. Not very steep, is it? All right, everybody good with number 3? Number 4 says, from the top of a 200-foot high tower, an air traffic controller observes an airplane on the runway at an angle of depression of 19 degrees. How far from the base of the tower is the airplane? So, once again, if you draw yourself a Z, you got your tower over here, it's 120 feet. Okay, this is 19 degrees, so that's 19 degrees. And you're looking for this distance here. So, we have a degree, we have the opposite, and what are we looking for? The adjacent or the hypotenuse?
Adjacent.
Adjacent. So what are we going to use? Tangent. So the tangent of 19 degrees is equal to the opposite over the adjacent. We got to move x to the other side of the equation, so we have x times the tangent of 19 is equal to 120. So x is equal to 120 divided by the tangent of 19. We are looking for a side, so we're going to use tangent, not second tangent.
Do you have to put 10 in front of it like that? Well, when it's 120 over 10, 19.
It's 120 divided by the tangent of 19. Close the parentheses. Okay. We get the distance is 348.5 feet. Any question about that one?
Why'd you put 120 over 5?
Well, the tangent is equal to the opposite over the adjacent.
Oh, okay, that makes sense.
So it's opposite. Now stand on the angle and walk opposite. So 120 is opposite. X is adjacent.